First, let me ask what you got for these examples. So, wall side of the classroom, x squared plus 0x minus 25. How did you end up factoring that one?
Wait, over here?
Oh, I'm sorry. I'm looking at my iPad instead of the screen. So let me. Yeah, no, this is backwards. Right. So let's do x squared plus 0x minus 36. My mistake. So for that one, wall side, how did you factor it?
I got x plus 6 and x minus 6.
X plus 6 and x minus 6. You can check that negative 36 has as a paired factors negative 6 and positive 6. They multiply together to give you negative 36. And those same two numbers add together to give you 0. Right? Okay, window side, x squared plus 0x minus 25. What did you get? Laura?
I got x plus 5 and x minus 5.
X plus 5 and x minus 5. Yeah, exactly. Again, those numbers plus positive and negative 5 multiply together to give you negative 25. And they add together to give you 0. So let me ask you this. What relationship does a pair of numbers have if they add together to give you 0? What's the relationship you're seeing here in the answers that you got for how to factor these? It's the same number. Well, it's equal and opposite, right? It's the same. These numbers have the same absolute value, right? If they add together to give you 0, that means that they both are equal and opposite to one another. And so that's an important observation, right? And the reason I wanted to do this example the way that we did it is that often this, x squared plus 0x minus 25, is not how you're given these problems in the first place. Usually, these problems will come at you looking like this. X squared minus 25. X squared minus 36. Usually you won't be given the luxury of seeing that 0x there in the middle. But if you do see the 0x there in the middle, that gives you a way to use the same sum and product game that we talked about today to factor expressions that don't have that middle term. So my recommendation is if you're given an expression like this that doesn't have that middle term, put your own middle term in there. You can always write plus 0x to remind yourself that that's what the sum that you're looking for should be. The sum should be 0. And if the sum needs to be 0, then, as you said, the numbers need to be equal and opposite. So add that plus 0x in there if you don't see it, and that will help you to solve those. What would you say if I changed those examples a little bit and put a plus here? What happens now? What do you want to change about your answer if I made these x squared plus 25 and x squared plus 36? Got any guesses? So we could try doing it with two negatives. So that would make this x minus 5, x minus 5, x minus 6, x minus 6. What do you think of that idea? Because now, negative 5 times negative 5 is positive 25. Negative 6 times negative 6 is positive 36. Does that work? Why not?
Because it's going to give you something in the middle.
Yeah, because when we multiply this out, we're going to get something in the middle. X squared minus 5x plus 25. So we'd end up with a minus 10x that we didn't have before. Likewise, over here, we'll end up with a minus 12x that we didn't have before. So just changing that sign from plus to minus is not going to be enough to factor x squared plus 25, to factor x squared plus 36. In fact, these are examples where no matter how hard you try, the methods we've learned today are not going to work. For the simple reason that we need two numbers which multiply together to give us 25 or 36, but which add together to give us 0. But if they add together to give us 0, that means that one of them has to be positive and the other one has to be negative. And if one's positive and the other's negative, and we multiply them together, what does their product have to be? Positive times negative is always negative, so it can't be positive 25. It can't be positive 36. So these are two examples of ones that cannot be factored. Not possible to factor. That's kind of one of the limitations of the method that we learned today, is that it won't work every time. No matter how hard we look, we're not going to be able to find a pair of factors, a pair of numbers which multiply together to give me 25 and which add together to give me 0. It's not going to happen. Last one I want to talk about then, before we talk about takeaways and we get out of here for today, is the ones on the bottom rows. x squared plus 10x plus 25 for the window side, and x squared minus 8x plus 16 for the wall side. How were these different from the other examples that you did? Window side, what'd you get for x squared plus 10x plus 25? Jamie?
X plus 5 squared.
Yeah. So you got x plus 5 squared, or x plus 5 multiplied by itself. X squared minus 8x plus 16, wall side?
X minus 4. X minus 4.
Yeah. You end up with the same factor repeated twice. And as Jamie said, that's often written in your final answer, rewritten in your final answer by taking this pair of factors which are the same and just rewriting them to say that this is really x plus 5 squared, or x minus 4 squared. The funny thing is, a lot of algebra textbooks, I think ours included, treat these last couple of examples here as something special. They put them in a different section. They call special attention to them. I don't think we need to really put special attention on those two, other than the special attention we've given it over the last 10 minutes. The sum and product game will get you through them, as long as, in these examples where you're missing a middle term, you just put in a plus 0x to remind yourself. And as long as your mind is open enough to realize that your two factors could be the exact same thing in the examples of factoring a perfect square.